Three ideas we haven't talked much about yet are work, power, and mechanical efficiency. Work is the process by which you change or transform your energy from one form into another. Work equals the change in energy. If you want 5 joules of kinetic energy, you better put in 5 joules of potential energy. It's transformed by applying a force over a displacement in the correct direction, that is, in the direction you want to go. Work equals the dot product of force and displacement. Work is measured in joules, where 1 joule is 1 newton of force times meter of displacement. Power involves time. It's the rate of doing work, the amount of work you do and the time it takes to do it. A normal student can write a 10-page paper in 10 weeks. A superpowered student can write a 10-page paper in 1 night, plus or minus a whole lot of coffee and the fact that they're probably in graduate school if they can write a 10-page paper in 1 night. Since work is changing energy from one form into another way you can track power is the change in energy over time. Power is therefore measured in watts, where 1 watt of power is 1 joule of energy transformed per second. What if we want to make a more powerful machine? What can we do? Let's take a look at the human body and see what we can do to increase the power. For example, the physics of bowling. Take a look at this bowler. Go Team USA. Look at that wind-up. Given that the power is work over time, the bowler can increase the work that they do by applying force over a longer displacement. Look at that video again and see what the bowler does with his arm, throwing it all the way back and making sure that the force is applied over a very long distance, the full reach of both his hands, from back all the way to forward, at least 6 feet. More work in the same amount of time yields more power. Now, physics of baseball and softball. Let's take a look at the pitch. How is it that we're going to increase our power here? Consider the time involved. Power is the change in energy over time. The pitcher is giving kinetic energy to the ball that she is pitching. Same mass, same maximum pitching speed, assuming she's already been working out. What we can do is decrease the time. Take a look at that wind-up. It happens very fast. If you deliver the same amount of energy in less time, you're going to get more power. A related idea is the idea of mechanical efficiency. When we talk about a more powerful machine, we don't mean a big machine or a strong machine. We mean a machine that can do a lot of work and transform a lot of energy in a very short amount of time. Efficiency is how much of that output is actually wanted. Some books say that efficiency is the energy output divided by the energy input. Well, that's just stupid, because the energy output and the energy input are the same by conservation of energy. If you put 1,000 joules in of electric potential energy from the wall, you're going to get 1,000 joules of output. There's no waste. No, what they mean when they talk about mechanical efficiency is useful energy output divided by energy input. How much of that output is in a form that actually does what the device or the person is supposed to do? Well, what kind of energy could we output? Let's think about it. Potential energy, electric potential, chemical potential, spring potential, gravitational potential. What do you want your machine to have the potential to do? Kinetic energy, is it going to move? Let's see, internal energy, sounds, thermal energy, is it going to make whirring, clicking noises? Is it going to heat up? Let's see, how much of that energy is actually useful? Well, nobody except Monty Python makes a machine whose sole purpose is to go ping or make little whirring noises or heat up its own gears. Even your heater isn't trying to heat up itself. It's trying to heat up your room, and it's trying to circulate air. There will always be a certain amount of internal energy in your machine because there'll always be friction in the gears. There's no such thing as a machine that never has any one part touching any other part. There will be thermal energy, there will be sound energy that goes to waste that you can't convert into anything that machine was meant to do. Even your speakers, which are meant to make noise. Music, good. Feedback, not so much. If there's always going to be internal energy, then the one thing we can absolutely say for sure about the mechanical efficiency of your machine is that it's less than 100%. Some of that energy output goes to internal energy. What's left is the amount of useful work your machine can do in one form or other. 99% efficiency, that's a good machine. 99.8% efficiency, that's a green star for energy efficiency. 100% efficient machine, no such thing.